Hi, Peter Temes here, founder and president of the Institute for Innovation in Large Organizations. I want to talk for a minute about an approach to machine learning called Federated Learning that has a lot of impact on how we practice innovation in large organizations. So just to take a quick step back, machine learning is when you have an artificial intelligence system and you need to feed it data, you need to teach it, right? There's a learning period that probably goes on forever, but that front end is vastly important. That really shapes what this extraordinarily brilliant system can do, what it will know, and how it approaches the learning that continues. Machine learning is called machine learning because you're not feeding in, sheets of paper to the machine. The machine is out there in an automated way, learning what initially we would call training data, and then as it's trained, more real data from a marketplace, from many sets of databases, from real-time customer interactions, from language, from social media. Federated learning is a particular approach that solves or purports to solve the privacy barrier to these systems doing what they really can do, but maybe we don't want them to do. Federated learning is something that's been developed and now is at the beginning of commercialization by Google. You may know that Google owns the Android operating system. Last I checked, there were something like 2.5 billion devices that use Android, including lots of phones, including medical devices, including all kinds of machines that need an operating platform, operating system. What federated learning does is it creates learning from data in relatively small buckets, but a very large number of those buckets, without taking the data from them or copying that data. The data remains private, but the structure of the data, the lessons that you can take from the data, go home to the AI system that's looking at them. So the way this works, for example, and this is a real case, our institute was asked by a major bank to look at how federated learning can be used for anti-money laundering, which is to say, to identify bad transactions or bad actors that are trying to wash dirty money so the banks can stop it. The way it works there is, let's say you're a pretty smart bank and you have a model that says, not only do I know the names of 1,000 money launderers who I never want to do business with, I know some aspects of how they approach my bank. I know some characteristics they have. So when I see new people who I don't know to be money launderers approaching to do transactions, or new transactions, even if they seem to be from a known person, that meet those criteria, that have those same characteristics as money laundering transactions, I'm going to block that. Maybe I'll then sniff around and give it a double check. Maybe we'll let some people in. But boy, it's valuable to know that first layer of information that you are probably, you are likely, you are maybe a money launderer. I have a regulatory obligation and a customer service obligation and a service to my shareholders so you don't do stuff that will drive me out of business to figure out who the heck you are and not let you into play. Now, if I have the names of, let's say, 1,000 of those money launderers, even better, without knowing their names, if I can look at the data on all the cell phones of all the people who bank with us, already you can feel that privacy itchiness. I'm looking at all their data. I'm not going to copy it. I'm not going to write down anyone's name. I'm not going to block anyone or anything based on looking at their data. But I'm going to go in and I'm going to say, out of 1 million people I've just poked around the phones of, I can see 50, 60 meet the criteria for being real money launderers. Now that I'm in their phones looking at their private data without copying it, without making an indication that they, as individuals, are the source of this signal that they might be money launderers, still, I can be in that phone and I can say, wow, not only do these 50, 60 people I've identified as money launderers, not only do they have those 100 characteristics in common that predict who's a money launderer, but now that we're in all their private data, we can see they have another 100, maybe another 1,000 characteristics in common. So what I've done is I've learned enough by being on those phones to be able to change my model without identifying who those people are. I'm not taking any data off their phones. And I'm not indicating in my database that these people sure do match what it means to be a money launderer, because I only know that by looking inside their phones and looking at their private personal data. All I'm doing is saying anyone who is a money launderer based on our model has these other characteristics. We can now take that learning to our model. So now instead of our model having 100 characteristics, maybe it has 1,000 characteristics. And now we can filter transactions and individuals by knowing a lot more about what a money launderer is, does, how that person acts. That makes a much safer system, right? Now, look at this in healthcare. The human gene has 3 billion matched pairs. And as we start looking for commonalities that people with certain diseases have in their genes, if I can look into people's genes without copying data, without identifying them in any way, but just saying, man, someone who is going to have diabetes in 10 years has these characteristics now, and we can help intervene and keep them safer. Someone who's going to have a preventable disease in 2 years has these characteristics much beyond what we thought initially. We have a model that identifies known hits, and then looking at the hits, we increase the utility of the model maybe by an order of magnitude. That's what we can do with federated learning. It will be a game changer because of what it does, not just technically, but in terms of privacy. The question we have to ask is, does popping in and modeling your data invade your privacy, even if we don't copy it, even if nobody notices who you are? If you say, yeah, that's okay, federated data will make the world better. If you say, that's not comfortable, that creates too many opportunities for invasion of privacy, then it might be a missed opportunity. If you're doing anything in a large organization that looks like future orientation, that looks like leading innovation, you need to know about federated learning. This is a topic we discuss around the table. We've been able to talk with some of the people who are driving this on the development side, engineering teams that have really been working and bringing this to market, academics and others who are early adopters. We love sharing these stories. We love being able to get people around the table who want to know this stuff, some of whom have never heard of it, but they want the flag and the early signal. Some of whom are thinking about it right now, like our bank member that said, hey, what would the use cases be for anti-money laundering? We'd like to bring you into these conversations. Talk about how a technology like this works, what your organization in any area might be able to get from it, but more importantly, share where you're coming from, share the challenges you're having now, and see what those other folks around the table, playing similar roles in other organizations, have to say, have figured out, what experiments they've already paid the cost of that you can benefit from. It's the Institution for Innovation in Large Organizations, the ILO Institute, and I hope you'll be interested enough to come and spend some time with us. Thank you.